I don't know if you've ever tried to create your own packet structure, your own little protocol to send across the wire, but it can be kind of fun. It's a good challenge, and I feel like everybody should at least at one point build some non-trivial project with their own encoding algorithm so that you too can learn why computer scientists tend to lose their hair. It's just such a great experience in having a horrible time debugging. And so, of course, I cannot help myself. I don't know. Maybe I'm a masochist. Maybe I just think it's fun. I honestly have no idea. So I yet again created a protocol on my own. And so the protocol is actually pretty simple. All it is the following. I have a version as my first byte. The next byte, by the way, you should always, if you're ever going to do your own protocol, you should always have a version. Like the oh shit handle of all protocols is you realize you need to add something or you need to make, say, more bytes for something. You need new flags and you have no room left and then you're gonna suck. It just life sucks. So by having this version, you can say, this is a version 1 protocol, but we only support version 2 now. Hey, person, you need to reset your game or update your game or refresh your website, and now you can be on version 2, right? Very, very important to kind of consider. So, anyways, so the first byte's to version. The next byte's going to be to type and encoding. The reason why I did encoding as 2 bits is that I wanted to be able to send up protobufs or JSON or my own custom formula, depending on how I want to do this. I don't know. It's going to be kind of like a fun adventure. I haven't really decided how I'm going to do it yet, but I just left it in there so I could have 4 options for the different types. Then I was going to have 64 different messages. I think that's probably more than enough than I need. And then after that, this is going to be 2 bytes dedicated to just data. How much data am I actually sending with this packet? So there you go. Very, very simple packet structure. Then I also created these nice little ASCII charts for how I'm going to do, like, say, authentication. I'm going to need the client to send up their auth ID. My auth proxy is going to validate that that ID is usable. Then I'm going to determine, say, the best game server to use. Then I'm going to connect to that, let that game server know this is a type client connection, send over the type client connection ID. Then the game details can flow back to the client along with the game config. And there we go. We are now authenticated. It's absolutely fantastic, right? Kind of fun, right? Building your own protocol, building your own sequence diagrams, kind of thinking about everything all the way through. Always really loved it. But the code is always kind of disgusting, but also really, really fun. Again, here's my custom encoding that we talked about. Here's the primary structure, a packet. A packet really is a series of bytes, and how big is those bytes? Now you're probably saying, well, why would you do that? Why wouldn't you just like slice it off? Why would you actually have a length property? Well, my general idea is that I was going to probably pool my packets so I don't have to keep recreating memory and data and then having garbage collection or whatever kick into gear. Instead, what I was going to do is actually just have it so that I over allocate how much memory I need and maybe say have 500 packets sitting in a pool that I can just keep on using over and over again and keep refreshing. So that's why I keep a length field around. And so to produce a packet, you just need to hand me a packet encoder, which is something I can read data from, something that's going to tell me its type, and something that's going to tell me the type of encoding. And that's it. All I need. And so that means for me to be able to, say, assemble a new packet from an encoder, all I have to do is create the maximum size. Well, right now, I don't have any sort of efficiencies. I didn't build the efficiencies. I know I'm over here preaching, oh, you could build all these efficiencies and memory pools and all that. But instead, here I am being a loser, and I'm actually not even doing the thing I said I was going to do. I should probably move this method as a method or this function as a method receiver, and then change the packet itself. Blah. Just shut up. You get the idea, okay? Um, Anyways, I just create a large buffer. Then I create a slice of the buffer after the header, right? So that way I have my little header, my control header, and then the rest of the data on the other side. Then I just simply read the data into that data on the other side. If the data is too large, throw some asserts. Hey, this should never happen. I should be smarter than this. Get my encoding type out. Make sure my type's not larger than 64. Easy peasy. Then also make sure that I have the correct version. And of course, add in the encoding. Read out the length of the data. Big endian, by the way. You want to make sure you use big endian. That's network order. Okay, kind of important. Use network order when you're doing network protocols. And bada bing, bada boom, get the packet back out. And now I have this packet object in which I can do fun stuff. One, a packet is also a packet encoder because I implement encoding, type, read, fantastic. But I also have this thing called data where I only get out the actual data portion of it. So that way I don't have to get out all the data. And I can also take a packet and just write it into any reader. So it just does this beautiful little thing right here. Absolutely fantastic. But where the real sauce comes into, okay, where the real fun is, where all the good times actually are had, is not in the packet itself in the construction, but it's in the framing. Okay. This is almost identical to something like the WebSocket protocol. You could pretty much take this, slightly alter it, and you would actually have the WebSocket protocol. Like the difference is with WebSockets, you have to have a length that if it's 126, you need to read the next 2 bytes. And if it's 127, you need to read the next 4 bytes, if I'm not mistaken. And then you also have a mask that you have to read out if there's a control bit that says it has a mask. So there's like only a little bit more in the WebSocket protocol, but this is pretty much the exact same thing. And so how I do it is I first have this item that allows me to keep reading out data or read an error as two separate channels from a reader. And I can also control it by context. So don't worry how I get the data. I just get the data. So then I do this for loop where I read out some amount of data and I copy as much as I can into my like temporary buffer that I just hold on to. Once I copy that all out, I then call this read function, which I probably should call it I mean, honestly, probably a little bit better to call it parsing. I hear there's a few hard problems in computer science. One of them is naming things. Here I am being terrible at naming. So if the amount of data I have inside this internal little buffer right now is larger than my header size, it means I have a header, which tells me everything I need to know about the packet. Plus, it means I have some data, which means I may actually have a packet. So long as the version is correct, which if it's not, we got a version mismatch. I need to shut down the connection. I need to ban the person. I need to call their mother horrible, horrible names, right? Like awful things I'm going to have to do here. After that, I read out again, big endian network order, read out the length. Then the full length, of course, is going to be the packet length plus the header length. Then I'm going to see, is the packet length equal to the payload size? If it is, if the max payload size possible is there, then guess what? We have ourselves a problem, max size. Else, I'm going to have this beauty right here, okay? This is a beauty. If the full length is less than or equal to the size of my internal buffer, well, guess what? I can then copy out my internal buffer into this out buffer. Then I can take my internal buffer and copy what's remaining all the way over, because remember, TCP may sometimes give you more than one packet worth of data at a time, so I could actually have two separate packets of data in a single chunk of buffer. So I have to do this like shifting over business, and then bing, I just emit out the packet from bytes, packet from bytes. I use assertions here because you know me and I love assertions. I love crashing my program when I have programmed something fundamentally stupid, okay? I want to be able to simulate my entire environment and have it reproducible, and then B, I want to crash the program when something unexpected happened, and then C, I want to be able to generate millions upon millions of different simulations and prove to myself I've written very good software. So all I have to do is just have a few simulations or a few asserts, and here's one of the asserts. I just make sure that you know what? I should have a good version, right? If I'm saying I can construct a packet now, I should have the correct version. I should be able to have a data length that's greater than 0. I have no empty packets yet. Now, maybe one day I'll change it and there will be an empty packet. And lastly, I expect the encoded data should be the same thing as the data length that I'm saying, right? Like those two things should be equivalent. Bang, out goes the packet. We're looking good. I've made sure everything's been checked, and I crashed the program when I've done something stupid. And so then after that, I just have some tests. Yes, I did write unit tests for this. I didn't do simulation testing for all things, because this is kind of like a rule of thumb I have when it comes to testing. And I think this is a good rule of thumb. If you can't get something reasonably correct in one try, you should probably just write a test. That's kind of my general rule of thumb. Sometimes I say it's like 2 tries, but if you ask me to sum a list of elements, I'm not going to unit test it. It's just, right? It's too easy. But if you ask me to, say, encode binary and decode binary, I'm probably going to get that wrong once. And I did. I got it wrong in a couple spots. And so there we go. So testing, I just create my own little test encodable, right? This thing should be in code, which means I'm not mocking. I'm just creating something that can be tested and inspected. Then all I do is create my test encoder, create a new packet from it, have a buffer that I just write my packet back into, and then I validate that these things do exist. And look at it, it does exist. It's absolutely fantastic. Then I also do a framer test, because again, framing, that one's hard. You know what the funny part is with the framing? You know what I got wrong? It's so stupid. Parse, there it is. I had an if statement here instead, right? That means I could only read out one packet at a time, which means that I'd get a bunch of data, I'd read out one packet, and then I'd wait for more data. What happened if I got 2 packets in? I would never even send it out. I was so stupid. So I just did that. Easy, easy. It's ridiculous, huh? Anyways, so I write into my buffer the same packet 5 times in a row. And then after that, I create a new packet framer, blah, 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 something with cancel. I just run this whole framer in the background. I use an error group. Never used an error group before, huh? Kind of exploring. It's kind of like college. I'm just trying new things. It's kind of wild, huh? And then I just do this framer. I just say, hey, framer.out range over it. I expect myself to get 5 of these packets, and I call cancel because I should only get 5. And there you go. The end. By the way, it makes you call cancel twice, which is kind of annoying. I don't really like that. I mean, maybe I should just call break here and then call cancel right here. I don't know. It just kind of bothers me that anyways, I don't know what to do here with this. I got to figure that out still. I don't like the looks of that. Anyway, so then I just make sure that I've been called 5 times. And then after that, I also make sure that when I wait, no error comes back out. The framer ran, everything was great, nobody erred, program ended, and we're all happy. And of course, the program ends when I call cancel. So there you go. There's me writing a custom protocol, and I even have a framer and I have the packet structure. So now all I have to do is like do all the hard work, which of course is actually doing this part and creating the reverse proxy to send all these messages through and everything. I've never really created my own reverse proxy other than like this type of reverse proxy where you just literally just, you know, just take stuff in and write it back and forth, right? That's not really that. This is not very impressive code right here, right? There's nothing in here that's very cool. I just wanted to just try it out myself. So there you go. I tried it out myself. But what I really want to do is actually create my entire game server such that the authentication and matchmaking is its own reverse proxy. And then I do all that fun stuff. I don't know if it's going to be a good idea. I don't know if it's going to be a bad idea, but hear me out. It's an idea. Am I right? Am I right? Huh? Yeah? We're going to see if it works out. And hopefully this server should be able to handle about 60 to 100,000 players playing Vim games. And by the way, I am making something called Vim Arcade. If you're curious about all the code, go check it out. It's actually on Vim Arcade. So GitHub/theprimogen/Vim Arcade, GT status, GT add, GT whoopsies, RM test, GT status, GT add this, GT status, GT create message, proxed out of my mind, GT submit. And there we go. Feeling good. The name is the Primogen.